go over this. So on this triangle one, we're using the fact that we know our triangle equals 180 and kind of using, it's kind of like a puzzle, using some other things we know to fill in the missing angles here. So first of all, the angles that are on the outside, and it's like this, where there's kind of this crisscross X happening. What are those angles called? What type of angles are those? Vertical angles. And vertical angles are congruent. Vertical angles, and we know that they are congruent. So if I know that this angle is 30, then this angle is also 30. And if this angle is 130, then this angle here is also 130. Okay. Now this is not vertical angles here. What's happening here is it's creating a line. This is a linear pair. And we'll talk about it more in a minute, but I don't, like, these aren't the same angle. Okay. So if I have 130 and I have 30, so far in this triangle, I have 160 degrees. So then what must this angle be here? 20 degrees. Now, linear pairs are supplementary. So if this is 20, then this angle is 160. Now, I did that and kind of, I ignored a theorem there and just showed how you can find what this angle is without using the theorem. Our exterior angle theorem also tells us that this angle is equal to these two remote interior angles. So I didn't actually have to do this to know that 17x subtract 10 is going to equal 160. Okay, so whether I know the theorem that it equals those two angles combined, or if I could just kind of keep going and get there, somehow we need to know that 17x subtract 10 is equal to 160. Or 17x equals 170, and divide by 17, and x equals 10. Good. On the second example, it also uses a vertical angle. So here's my vertical angle, which tells me that this is 47. And so now I kind of have two choices on how I could set this up. I could just put all of the angles, add them all up and set it equal to 180. That's one option. Or sometimes I like to do like add up what I have so far. So that's going to give me 122. Okay, so I know I have 122 degrees so far. So how many degrees must that third angle be? 58, which is doing 180 subtract 122. So that means that this angle is 58. And it just gives me like a simpler equation to set up. Instead of saying this angle plus this angle plus this angle equals 180, if I know two of them, I usually figure out what that is and then subtract from 180, then use that equation. So then I just have to subtract 66. And x would equal what? -8. So now I think I'll give you a couple minutes if you were kind of stalled out to try to get either 3 or 4 done in like a minute, I'll say. And then we'll go over it. So what did you use here? What do I have? Let's start here. What would this angle be? 60, because it's creating a line. So I know that this is a 60-degree angle. I know that this angle is vertical. So I would have how many degrees here? 100 degrees here, which means that this angle would be 20 degrees. And therefore this angle out here is 160 degrees. Okay, so I can just find this angle by working my way through. I also know that this exterior angle has to add to the two interior angles, which is 160. However you get there, here's my equation. And then I subtract 172, and I get x equals -12. 4, same idea. So, oops. So we have vertical angles right here. I know that this is 130. If I have 130 and 20, then this remaining angle in my triangle would be 30. Okay, this I would not use the exterior angle theorem. Okay, this is just a vertical angle on the outside. So if this is 30, that's 30. Or x plus 34 equals 30, and x equals -4. Okay. So now what I'd like for you to find is in your notes packet, we're going to kind of switch away from triangles today. Okay, and look at polygons in general. And we have this big table at the beginning of notes 3 for you to find. And as you do this homework tonight, you can use a calculator on this stuff. I guess probably I'll let you use a calculator on the quiz, just because some of the numbers get a little tricky. We're not actually giving calculators this year, just sharing material. So hopefully you have a phone that has a calculator on it. If not, just let me know. I can probably find one somewhere that we don't use often anyway that you can kind of keep until the end of the year. I don't know, we'll figure something out. I don't know how to do that on quiz day if you need a calculator. I didn't have Chinese food until I was like 20, maybe.
I tried chicken.
And I was terrified. I really was. Like, I was terrified. I thought it was going to be so disgusting. It's delicious. I should have really gone there way before.
I tried chicken wings for the first time a month ago.
Did you like them?
They're Chinese chicken wings.
Oh, okay.
They were pretty good.
Yeah.
I like spice. So.
Mm-hmm.
Corn, never tried that.
Corn?
Yeah.
You've never had corn? Oh,
Gravy.
Lord.
Cranberry.
Corn on the cob. Let me tell you. Okay, hold on. All right. So we are going to add polygons. We're going to get away from triangles a little bit. But a polygon that has 3 sides is called something with 3 sides is a triangle. Yeah. So this is like the only polygon we've spent a lot of time with so far. And how many angles do we have inside a triangle? Yes. How many angles, what's the total angle sum when I add up all of the angle measurements? 180. Yeah. So the sum of our interior angles of a triangle is 180. So we have a triangle and we know that it totals 180. Okay, I'm writing that over to the side for a reason. It's going to help us when we get down here. The average interior angle, which means if all of my angles are the same, if it's divided up equally, then each angle would have to be 60 degrees. Okay, so that's what that question's asking. It's saying, well, if I have 180 total and if I divided it up evenly between the 3 angles in our triangle, we'd have 60 degrees. The average exterior angle, so again, same idea. If my triangle was equal angular, so they were all 60 degrees, then what must the exterior angle be? 120.
You figure that.
Because that exterior angle is going to create a line.
Oh, okay.
Okay, and I could do that on any side. So I could have an exterior angle over here, an exterior angle over here. Notice that these 2 values are supplementary, right? Okay, it's creating a line. So if it's 60 inside, it's 120 outside because it's going to create that linear pair. Okay, so how many exterior angles would I have in a triangle? If I had all of them, 3? 360. So 360, yeah. So the sum of all of them, meaning if I took all 3 of these, I would have 360 degrees. And then this is each, and this is all of them. Okay. So we've done some work with triangles. That wasn't too bad. Something that has 4 sides. Let's see if we can get there. Could be a square, could be a rectangle, could be a parallelogram, could be a rhombus. There's all sorts of things with 4 sides. What's the general name? Does anyone know? Quadrilateral for our sides, yeah. quadrilateral. Now a quadrilateral, okay, there's my four-sided shape. I could have drawn any four-sided shape, but I gave us kind of a rectangle here. I can take my quadrilateral and I can break it into two triangles, which means I'd have 180 degrees in both triangles. That should help us know how many degrees total would we have in our quadrilateral?
360.
360. Every four-sided polygon, whether it's a square, rectangle, rhombus, parallelogram, we have 360 degrees inside a quadrilateral of any shape. And how many angles are there in a quadrilateral? How many angles? I'm always going to have 4 angles. So then each angle, if I divide it up equally, would be how many degrees? 90. Think of a square or rectangle. Those are 90-degree angles. And if in my quadrilateral, draw up image again, if I have 90 degrees inside, what would my exterior angle be? 90 as well, because it has to add up to 180. Again, they're supplementary. And if it is 90 degrees for each exterior angle and there are 4 exterior angles, what's the total? 360. Yep. A 5-sided, big fan of 5-sided polygons. Here's my 5-sided polygon. It looks like a house.
No.
Does anyone know the name of a 5-sided polygon?
Quintilateral?
No, but good guess with the quin. Pentagon. Yeah, kind of switches. Pentagon. Now,
Sorry.
in my pentagon, look at me. I took my pentagon and I broke it into triangles so I can figure out how many angles total I have. So I have 3 triangles here, which would each be 180 degrees. Oops. So then how many degrees total do I have in my pentagon?
540.
540 degrees total. Now up above, we get our average interior. We just did this and we divided by 3 and we divided by 4. And we're going to do the same. We're going to divide by 5. So let's break it apart. How many times? If I take 500 and divide it by 5, that's 100. 40 divided by 5 is 8. So that's 108 degrees for each interior angle. Again, I could draw a little, I'm not going to probably draw the next one. Here's my pentagon. If I have 108 degrees on the inside, then my exterior angle would be how many degrees? 72 degrees. Now here comes the tricky part. 72 to get here, we kept multiplying. This was, we multiplied by 4, we multiplied by 3. If I do 72 and we multiply by 5, well, what's 70 to multiply by 5? 350. 2 times 5 is 10. Add them together. 360. Noticing a pattern in that last column?
All 360.
They're all 360. Okay, a 6-sided. See how I do here.
Excellent.
Hexagon.
Now I gotta
Didn't
think
do
back to
very good.
chemistry.
A hexagon. One time I had a friend whose son went as a pentagon for Halloween.
Wait, how?
He just loved him, so they made a cardboard pentagon and he wore it around. That was like kindergarten. It was adorable. Now a hexagon, you may guess, since I had 1 triangle, then 2 triangles, then 3 triangles, 1, 2, 3, 4 triangles fit inside a hexagon. That means I would have 4 times 180.
3,720.
Yeah, it would be. 120 degrees. And then to get the average interior angle, I divide that by 6. which would be, I'll just tell you, 120. And we've seen this pattern that it's creating a line. It's always supplementary. So if my average interior is 120 degrees, then my average exterior would be 60 degrees. And I have 6 of those 60-degree angles, and 60 times 6 gives me 360. What a coincidence.
It's
So
gonna get ridiculous, I feel.
it's getting ridiculous. Now, what are you noticing is happening each time we are adding 180 more? So instead of me trying to draw these, which I can't, I don't even know, 7-sided, what that exactly would look like. It would take me a minute because it wouldn't be even, like this is even on the sides. We're going to use that to fill in the rest, and we'll kind of work off of there. Now, 7-sided polygon actually has 2 names that it could go by. One is a heptagon, yes, and the other is a septagon. Now, you may not know that, like, okay, so hold on before we go on. What's an 8-sided? It's a stop sign.
Octagon.
An octagon. 9-sided is a nonagon. 10-sided is a decagon. 12-sided is a dodecagon. 15-sided is a pentadecagon. We're leaving that last one blank right now. Okay, now what you may not know, do you see the beginning of September, October, November, December? You see it there?
Yeah.
Yeah, and that corresponds to 7, 8, 9, 10. And you're all saying, but Mrs. Sawyer, December is the 12th month, and this is the 11th, and this is the 10th, and that's the 9th. Yes, and I always forget why it got shoved around, like something about farming maybe and daylight savings, but originally, that's why those months are named the way they are, is it was supposed to be the 7th, 8th, 9th, 10th month. But then somehow things got shifted around and months got added in.
You know, I remember I had a funny way of remembering the chemistry. You had to remember Nona.
Yeah.
I would always go, it's no na.
That's how you remembered it?
Yeah, no na.
Glad that worked for you.
Yeah.
I also didn't know you to do, so what do you do in chemistry with these?
Oh, it's been a while, sorry.
Is it like the shape of whatever
I think it's like,
I can see it in my mind,
I know.
but I can't like the bond between the two
Yes.
things. And then, yeah, I can see it in my mind. I can't think of the right word though.
We didn't get a dodeca though.
Well, no, we have 12, we have dodeca.
Oh, no, I mean, chemistry, you only went to deca.
Oh, I see. Okay, so we've seen this increase of a triangle with each increase in side. So if I add another triangle, how many degrees would my, if I add 180 to above, how many total degrees would this be?
900.
900 degrees. Now this one gets tricky. This is part of the reason why we use a calculator. 900 I cannot evenly divide by 7. So we're going to round it to 128.6 degrees. Okay, so if I divide that, it doesn't go in evenly. There's my decimal. And so then if I look at my supplement, I have 51.4 degrees. And I think you'll take my word that the exterior, I think this is rounded. This might be, I don't know. I'd have to grab my calculator and look. Because this isn't 4 times 7 is going to be an 8 ending there. So it's not quite exact, but it is 360. That's the only one that I have a decimal for. For my octagon, if I add another triangle, where am I going to land?
1080.
1080. And dividing that by 8 sides gives me 135 degrees for each angle inside my octagon. Now we don't have a decimal, so I think you can tell me what's the supplement to that. 45 degrees. And what do you think 45 times 8 is? 360. Add another triangle.
1260.
1260. If I divide that by 9, it gives me 140 degrees for each interior angle, which the supplement to that would be 40 degrees. And 40 times 9 gives me 360.
Oh, that's what you're doing.
To get the 360,
No, I just, I was
Oh.
wondering, like, where do you get the 40? Oh, it adds up to 180.
adds up to 180. Yeah, those two. 10 sides, adding another triangle.
1,340?
1,440.
440.
And dividing that by 10 is 144. The supplement to 144 is
36.
And 36 times 10 is
360.
360.
Oh my gosh.
Now this one's tricky because this one we're skipping 2 sides. So an 11-sided polygon would be adding 1 triangle. A 12-sided polygon means I'm adding 2 triangles, or I'm adding 360 to this degree measurement.
1,800.
1,800. Dividing that by 12 gives me 150 degrees for each interior angle, and the supplement to that would be
30.
and 30 times 12 gives me 360. Now this one we're just gonna give you. This is adding 3 more triangles. Gives me 2,340 degrees inside a pentadecagon, a 15-sided polygon that I'm not even going to attempt to draw. And the average of each interior angle, if I take that and divide it by the 15 angles that are there, would give me 156 degrees for each angle. And that would be 24 degrees. And 24 times 15, hey, look at that, gives me 360. And what happens, the more sides you get, the more it starts to look like a circle, right? So like it's kind of like those interior angles are getting bigger, the exteriors are getting smaller because you're just adding sides. It's kind of going to eventually look like a circle. So n number of sides. So we will see some that say like a 23-gon. Okay, I can put in any number of sides, call it an n-gon. Now here's the important piece. N is unknown right now. So now we're going to fill in how could I find any number of sides, each of these things. Let's start with the easiest one. Any number of sides, what's the sum of the exterior angles?
360.
360. I don't care what the number of sides is. It could be a 100-gon. Okay, it's always going to add up to 360 around the outside. This isn't always. Okay, that's the easiest piece of this. Although, ironically, the most common error, okay, because you're going to get asked a question on a test that says, what is the sum of the exterior angles of an octagon? And you're going to use a formula of some sort, but you don't have to. The answer is just 360. And the answer is always 360 to that question, no matter what the polygon we're looking at. Okay, so it's like the easiest question and also the question that kids get wrong all the time.
So even if it's 200.
Doesn't matter. So it's gonna be 360 for the exterior angles. Now, let's figure out this one. How many triangles were in my triangle? 1. Okay. So I just want to point this out, and I kind of want to be able to erase it. I'm gonna put a little note next to our number of sides. I might not have a pencil. I didn't come prepared for class. That's okay. I won't be able to erase it. That's okay. Okay, so this had 1 triangle. How many triangles were inside a 4-sided shape? 2. How many were inside a 5?
3.
How many were inside a 6?
4.
Okay. I see the pattern there. Then there was 5. And there was 6. Based on the number of sides, the number of triangles within the shape is always how many less than the number of sides? 2 less. Yeah, so if I have 4 sides, I have 2 triangles. If I have 5 sides, I have 3 triangles. If I have 9 sides, I have 7 triangles. Does that make sense? So my general formula is however many sides I have n sides. If I take away 2 from the number of sides, so if I have 12, I take away 2, I have 10 sides. Okay, I have 10 triangles. 10 times my triangles, look at that. Okay, you see it there? 10 times my triangles.
Yeah.
So always 2 less than my number of sides times 180. That is how we figured out how many angles there are inside of each of those polygons. And so given any number of sides, I can figure out how many angles there are within it by using that formula. And then to find the interior angle, we just took our sum. I just rewrote this formula. Two less triangles than the number of sides I have. So I multiply that by 180. I took my sum and I divided it by the number of sides. I divided it by the number of sides. That's how we found each angle. Now then we used that to find the supplement of the other one, but we wouldn't use this formula if we didn't have to. If we were just asked to find each exterior, we can take the total, which is 360, and just divide it by the number of sides. Okay, because the total is always 360. That's easier than going the other way. Okay, where n equals the number of sides.
Brownies, you haven't tried brownies.
What?
I've tried vanilla brownies, but.
Ew! I wouldn't even try vanilla brownies.
Well, they're homemade.
Like the blondie brownies.
They're homemade.
Man. You know who would be disappointed in you, Jaden? My mother.
I know.
He'll never learn. So I kind of feel like we're not going to worry about these words. In other years, we went a little bit more into this. Convex, meaning like it's not, the angles aren't, angles, this is a regular polygon. So like we're going to see these words sometimes convex or regular. So like the polygons you think of. Sometimes you could create a 5-sided shape that's concave, meaning like it goes in. So here's 1, 2, 3, 4, 5. Anything that has 5 sides is technically a polygon. We're not talking about these. And in fact, we're only really talking about this together. So regular polygon, meaning all of the angles are the same. So like we're not talking about these like a regular polygon, like my triangle. Here's my regular convex triangle versus this would not be a regular triangle because all the angles aren't the same. Same idea with like my pentagon. Like I could have a pentagon like this. We're talking about our traditional pentagon that's in the shape puzzles we did when we were little kids, okay? Our regular polygon figures. But really we talked about these because in the homework and stuff, you may see these words. Okay, we're assuming that all of these look like our regular, typical, standard shapes. We're just gonna fill in our formulas one more time. So our sum, we use n minus 2 times 180, where n is the number of sides. Okay, and that works because we always have 2 less triangles within a shape than the number of sides that that shape has. If I want to find each angle, then I need to do the same thing, find the total, but then divide it by the total number of sides that that shape has to find each individual angle, which again, we're talking about shapes that all the angles are the same. Easiest one, the sum of my exterior angles is 360. So therefore each angle is that sum divided by the number of sides. Okay, so let's look at a few of these and then you'll get some practice on your homework. And tomorrow's like a review day, Monday's a review day. You must be taking the test on Thursday next week when I see you next. The other group's taking it Tuesday. Yeah. Oh, I should get you Unit 5 stuff today just in case. Yeah, I'll do that at the end of class. So this is what this section of notes, this is what it's going to present as on homework, quizzes, whatever. It's just a sentence. You got to read it, figure out what equation to use, and how many sides. That's the other key thing, is how many sides is it talking about. So first equation, it says sum of the interior angles. Well, my equation for the sum of the interior angles is n minus 2 times 180. Okay, that's the formula I can use to figure out that result, okay, without just cheating and looking back at my chart. The other piece here is it gives me the polygon name. So I need to know from this, how many sides does that mean? How many sides is an octagon? 8, which means putting the two of these together, I have 8 minus 2 times 180. or I have 6 times 180. And I will let you use a calculator. I'll tell you right now, until you get phones and homework out, that gives me 1080. Your Chromebook also has a calculator, by the way. It actually has a nice TI calculator. If you ever look in the apps, they put TI calculators in all of them. Okay. So then number 2 is definitely a little more challenging. So it says what polygon? So how many number of sides? So what polygon, meaning we don't know how many sides, but we do know that the interior angle sum, so same formula, at n minus 2 times 180, I got excited there and wrote my equal sign, that my interior angle sum is 1260. Okay, so I do not know what n is, but I do know that my interior angle sum is 1260. And I can solve an equation like this. So what you need to do here is solve. I would distribute the 180. I could have divided at the beginning too.
Well, it's one more than a previous one.
Yeah. So I have 180 minus 360 equals 1260. And then I would add 360 to both sides. I'd get 180n equals 1620. Okay, so now I'm just solving an equation. So I have the formula. I know the total is this. And I'm distributed and I'm just solving for n. And if, again, you'll have a calculator if you're struggling with the division piece here. Dividing that by 180 gives me 9. Now, if it's a polygon that we should know the name of, so I've listed certain names, you should know the name of those. So instead of just saying, well, it would be a 9-sided, yeah, we're going to use the actual name, which is a nonagon.
No, be gone.
Nona? Sounds like a grandma.
I know.
My grandma, we call my grandma.
You, Nona? That's a good one.
I'm Nana.
I'm like disappointed in, my mom has a special name. So my mom is Amma, like mama without an M. So she's an Amma, not a grandma. But like my stepdad didn't get like the same. So he's just like, I mean, he's Papa, so he's not Grandpa. And I'm like, I feel like we should have gone, like if we were going to give one person a weird name, we should have gone with it
I have a uncle.
full on. But, and we have 2 Papas, so that makes it hard. Like both Grandpas are Papa. So we never know who we're talking about. Really. It's too late in the game to change it now. Okay, let's see who can get this. What is the sum of the exterior angles of a 16 gun?
360.
360. Yeah, this is one kids always get wrong. I don't care if it said 26 gon. Sum of exterior angles, I'm done. I can answer the question. It's 360. What is the measure of each exterior angle? That equation would mean I'd have to take 360 and divide it by the number of sides,
10.
which is 10. Yeah, so that's the other piece. We got to be able to pull out what n is. So it's a decagon. That's 10. Plug that into my formula. 360 divided by 10 gives me 36 degrees for each exterior angle. Okay, last one. This is probably the trickiest formula. So it says the measure of each interior angle. So each interior angle, that formula is find the sum and then divide it by the number of sides. So what is n here? A pentagon. What would n be? 5. Yep, a pentagon is a 5-sided shape. So now I'm going to plug in 5 to my formula. 5 subtract 2 times 180 over 5. Or you could have just gone right ahead and said, well, 2 less than 5 is 3. I don't have this one written down, so we're going to work through it. 3 times 180, what is that going to give me? 540. It's going to give me 540 over 5. And what is 540 divided by 5? 108. Yep. Okay, so that's kind of what these will look like, where you're given a sentence, you gotta know what formula should I use here and how many sides do I have? And I plug in, and again, you can use a calculator to work through the math. Okay, so I don't think I have the homework up here. So what you have, you have a lot of time. I feel like I felt like that was a longer lesson, but look at how much time we have. You have lots of time to work on this. If you haven't done the checkout yet, or if you're missing anything to submit, I would start there just to make sure you don't get too far behind. So if you haven't done the checkout, I would do the checkout first. If you haven't done the critical thinking for the last unit, that it looks like this. I'm missing a lot of these.
Oh,
I can make more copies if you need me to. So if you have that, we could look at that and I could help get you started if you're stumped on that, or if you have it, pass it in. Okay, I can go make a few copies. But you're looking at homework 21. If you have all those things in, homework 21 is going to use those formulas. You're all done. What I'm going to go grab unit 5 for you. And